Good morning, students. So today we start with important chapter, that is infrared spectroscopy. So this chapter belongs to the paper number CG 412. That is the name of the paper is applied chemistry. So this infrared spectroscopy, in an earlier lecture we have seen that this how it works, or the how this infrared spectroscopy is used for the detections of the functional groups in our organic compounds. So today we see the what are the key application of this infrared spectroscopy for the identification. So first application of this infrared spectroscopy is identification, identifying the unknown organic and the inorganic compounds. So this is the first application. So this first application is identifications of the unknown organic compounds. So these unknown organic compounds are the classified by using the different types of the functional groups. So there is a presence of the different types of the functional group. There is OH, carbonyl, amine, ester. So these functional groups are the detected by using the infrared spectroscopy. So every functional group gives different types of the unique band. So by the comparing with this absorption frequency, we can analyze different types of the functional groups. Then, so this by using this in IR spectroscopy, we can analyze the functional groups also. So determine presence of group like the OH, there is carbonyls and the amines. So this OH group is absorbed at a specific it has a specific absorption band. Carbonyls it is also has a specific absorption bands in, and the amines they are also has a specific absorption bands. So by this comparing with these absorption bands, so we can analyze the which type of the functional groups are the present in our organic compound. So this IR spectroscopy, it has also the different types of the applications in the forensic, that is analyzing the fibers, paints, drugs, polymers, and the explosives. So this every material, that is fibers, paints, and the drugs, polymers, are the explosives, are also the analyzed by using this infrared spectroscopy. It gives a specific or the important informations about these materials in the forensic science. This higher spectroscopy, it has also the applications in the pharmaceuticals. In pharmaceuticals, it has the application, there is characterizations of the drug encapsulations or the metabolism. It has it has a best applications for the characterizations of the drugs by analyzing the which functional groups are the present in our drugs, or the in metabolism process, how these drugs molecules are converted from the one to the another metabolite. So these metabolisms of the drugs can also be identified, or the IR spectroscopy helps in identifications of the metabolism process of the drugs and the drug encapsulations. In the food science also, there it has an important application, that is that authentication of the food products. So these food products are uh, the purity of these food products are also determined with the by using this infrared spectroscopy, or the determining the determinations of the origins are of the food products are also the determines bond vibrations. They are also have the applications in the bond vibration, that is the stronger bonds and the lighter atoms vibrate at higher frequencies, wave numbers. Functional groups, specific functional groups, different bonds, that is by using the different functional groups are also the identified. So the infrared spectroscopy, it has a variety of applications. With other than this variety of application, it has a variety of advantages also. It is a non-destructive. It is a non-destructive. Leaves the sample intact. So the sample used for the characterization. So yeah, it is it is not destructive. It is not break down into the sample is not breakdown. So it is versatile. It works for the solids, liquids, and the gases also. This characterization technique is used for the if the sample is present in the three states, solid, liquid, or the gases. So we can characterize sample by using this all the states. And it is also the rapid. It is a fast analysis time. So in the short time, so we get this characterization. Characterizations data of our organic compound. So these are the various different application of this infrared spectroscopy. So this infrared spectroscopy, it is a characterization technique used for the characterizations of the various organic compounds, organic materials in the forensics, in the pharmacology, in the chemistry, in the physical chemistry, in medicinal chemistry. So in every sector it has application. So it works on the interactions, absorption, detection, and the unique spectrums technique. These are the four terms. So these are the four terms are the importance for in the IR spectroscopy. That is interaction. So first is interaction is done. Interaction is done between the infrared lights with the material. Then this light is absorbed by the material, and the detection. And third, unique spectrum detection means how much amount of the light is absorbed. So by this our material is absorbed and it is detected with the by using the IR spectrum. So this IR spectrum gives unique IR spectrum. It is called as a fingerprint. It is like a fingerprint. So this, if every man it has its own fingerprints. Like this, every functional group it has its own fingerprints. Means we can characterize the all the functional groups are the present in our organic compounds by using this fingerprint region.